In this video, we're going to talk about confidence intervals specifically for proportions. Any confidence interval that we talk about is always a matter of inference, meaning that we're taking information, and let me just draw as I explain here. Um, we're going to use information from a sample to estimate information about a population. Okay, so we always refer to that word statistic that goes along with the sample. So we're going to use more specifically a statistic to infer about a parameter. Remember, we use that word parameter as a measure for any number dealing with a population. Okay. The third thing, when I think about confidence intervals, it's mostly used for, I like to say, unknown parameters, but yet still useful parameters. Okay. For example, if I were to ask you um, the percentage of adults who drink seltzer water on a daily basis, I wouldn't know where to begin on figuring out how many adults drink seltzer water on a daily basis. However, if I'm the manufacturer of vintage seltzer, I'm probably going to want to know exactly how many adults are going to drink this beverage on a daily basis. Um, Unless we do a census, which that would never be a question on the census, we're never going to know that true parameter. But what we could do is we could calculate the percentage based on a random sample of, say, 100 consumers at ShopRite, and then use that number to estimate what the true parameter is going to be. Now, let's use that example. Let's say we calculated out of, we'll say, out of 200 randomly selected adults, we'll say 40 drink seltzer. Occasionally. Okay, so how would I calculate? I could do a quick percentage here, do 40 out of 200, and say that 20% of adults are going to drink seltzer, but that's based off of one sample. So instead, I do what's called a confidence interval. Okay, and the confidence interval equation, my pen's being a little goofy here. Let me rewrite that. The confidence interval is equal to p hat, or the sample um, proportion, plus or minus. We're going to put z star here. I'm going to explain what that means in a minute, and then multiplied by the standard deviation. Okay, and just so we remember, our standard deviation with a proportion like this, anytime you're dealing with a sample proportion or a percentage, um, all you need is that p hat value. Standard deviation is equal to, again, the square root of p or p hat, either one. It doesn't matter. 1 minus p hat, sometimes called q, all over n, and we'll calculate that in just a minute. But let's talk about um, this other variable here, z star. Okay, and before we get into what z star truly is, um, I want you to think about if we were to calculate a 90% confidence interval, a 95% confidence interval, and we'll do all of these in a minute, and we'll say a 98% confidence interval. Okay, without knowing anything about confidence intervals, I want you to think about something that you feel 90% confident in doing, something you feel 95% confident in doing, something you feel 98% confident in doing. There's probably a lot of overlap between those three because it's not a big difference in percentage. But I think we could all agree that as we go left to right on this spectrum, as I increase my level of confidence, okay, I need to be sure that what I'm saying is correct. So typically, what happens, I shouldn't say typically, always what happens in statistics, as we increase the confidence level, the margin of error or the width of that interval will increase. Okay, so that's an important rule to look at. I'm going to say as confidence level increases, intervals get wider. Now, what does that mean for us in terms of the equation? Well, depending on the confidence level, does my sample proportion change? No. Depending on the confidence level, does let me just underline that. And does my standard deviation change according to confidence level? No. What does change, however, is this interesting little piece of the equation here, which is called z star or critical z value. Okay, and basically, the higher that our confidence level is going to be, the higher this number is going to be. The lower our confidence level is going to be, the lower that z star is going to be. Now, how do we get z star? Okay, I recommend by starting off with drawing a visual. So how do we get z star? Okay, let's say we had 90% confidence. So 90% confidence interval. Draw a normal curve, okay, and then visually represent where would that 90% be. Okay, it's always in the middle, 90%. And then where the critical z value comes into play is understanding the area of the tail ends. In other words, this area right here is 5%, and this area over to the right is also 5%. What I need to do is I need to get the corresponding z-score for both of these areas. Now, you could use either number because you're going to get, one's going to be negative, one's going to be positive. But what I typically would do in this case is I want to use my z-score chart and look up a number as close as I can get to 0.05. Okay, so let's do that. Let's go over to our z-score chart. And again, we're scanning the middle of this to figure out where 0.05 is going to be. The closest to 0.05 on the dot. Okay, so here I have 0.0505. Here I have 0.0495. I could use either one. Okay, they're both pretty close. I'm going to use the 1.64. Okay, you could use 1.65, 1.64 if you want it to be exact. Okay, but I'm going to use 1.64. And again, where I'm getting that number from is just working backwards, using this proportion and working backwards to get, okay, I see a negative 1.6 here, and then up to 0.04. Okay, so that's my critical z-score for 90% confidence. Okay. Okay. Now, this would be for, again, for 90% confidence interval. Okay. Typically in this class, in most classes that I teach, I always want us to calculate a 95% confidence interval, and that's why I bold this. The reason being is there's a shortcut for getting the margin of error. We could use 1 over the square root of n, okay? But also the z-score for 90 or 95%, I always instruct students to use 2, okay? And it's just an easier number to work with. Instead of using 1.64, we use 2. But even 2 is an estimate. Okay, I'm going to show you why in a second. If we did the same process for 95% confidence, okay, here's my, again, my normal curve. And we're going to try and make the 95 a little bit wider. So here's my 95%. And then the tails are going to go, they were 5 over here to the left. Now they're going to be 2.5%. Okay, 2.5%. So instead of looking up 0.05, in this one, I'm going to look up 0.025, or as close to 0.025 as I can get. And you're going to notice it's going to be pretty close to 2. Okay, so let's do that. So 0.025, again, we're looking in the middle here. So 0.025, we actually get it exactly here. And it's negative 1.96. Okay, so again, we go back here, it's negative 1.9, and then up here, it is 0.06. So my critical z-score for that is technically, I'm going to write it over here, because technically it's 1.96. Okay, but for the sake of this exercise, we can always just use 2. Okay, let's do the last one. Okay, we use 1.64 for 90%. We use 2 for 95. So 98 is going to be even bigger, right? And again, that kind of goes in line with the statement that we just made that says that as confidence level increases, intervals get wider. Okay, so without drawing the diagram here, because we can kind of get the picture, 98, we'll actually just do it on the bottom here. If we had 98%, I would be left with 1% and 1%. Okay, so I'm going to look up. Again, we're going to try and figure out as close as I can get to 0.01. All right, so let's figure that out. 0.01 over here. This one's pretty close. This one's probably closer, actually 0.099. So I'm going to use 2.33. Again, working backwards, I go back to negative 2.3 and then up to 0.03. Okay, so I would use 2.33 for 98% confidence interval. Okay, so that shows you the relationship between changing the level of confidence and then how the width of the confidence level increases or decreases. Now, let's go back to our initial example. I'm going to jump back up. Okay, we're going to use this example of how many adults drink seltzer on a regular basis. I'm going to calculate the 95% confidence interval. Okay, so we had 40 out of 200 in our sample. Okay, so to calculate a 95% confidence interval, we'll do it down here. We'll say 95% confidence interval is equal to, I'm just going to rewrite the equation again, plus or minus critical z-score times their standard deviation. Okay, so let's quickly calculate p hat over here. We've been throwing out that it's 20%, but just why is it 20%? Well, we have 40 people out of 200, which gives me, again, that percentage of 20%. So our equation is going to look like this, 0.20 plus or minus. Now the z-star, again, for 95% confidence, we're just going to use a 2. And then our standard deviation, we're going to do a little bit of calculation here. It's the square root of p hat times its complement, or 100% minus p hat. So it's going to be 0.2 times 0.80 all over the sample size of 200. Okay, we can use our calculators to get that. So we're going to have 0.20 plus or minus 2 times the square root, and I'm just going to break this thing down a little bit. So it's going to be 0.16 divided by 200. All I did was multiply 0.2 times 0.8. So we're looking at 0.2 plus or minus 2. Now let's take care of this decimal inside. So I'm going to use my calculator here, and we're going to get 0.16 divided by 200, and I get 0.0008. I'm going to divide that by, I'm going to take the square root of that. And the square root of that, if you give me 1 second here, is 0.028. So 0.028, and the decimal keeps going on and on, but I'll just ask you to round it to the nearest, usually the nearest hundredth place. So I'm even going to make this, just to make things easier here, let's say 0.20 plus or minus 2 times 0.03, 3%, okay? And that's fine, we can do that. So what this works down to is 0.20 plus or minus 2 times 3% gives me 0.06. So I'm going to add it and subtract it. And I always like to make like 2 little equations here. Just helps me. So 0.20 minus 0.06, 0.20 plus 0.06. And we're left with 0.14. And then over here we're left with 0.26. So this is our 95% confidence interval. Now the important part is we need to interpret this. So how we put this into work, I would say I am 95% confident that the true population, we'll say percentage. I always like to take it back to percentages. It's just more practical. The true population percentage of adults who drink seltzer is between 14% and 26%. Okay. Again, I can't say much more about the fact that it's somewhere between those two numbers based on my sample because I selected that sample randomly. Okay. I'm going to follow up on confidence intervals in the next video, but hopefully this gives you a brief overview of the difference between confidence level and the width of confidence intervals, and then most importantly, how to calculate a confidence interval.